Okay, illustrative math, unit 3, lesson 15 is called working backwards. All right, so our goal today, I can find real and imaginary parts of complex numbers if I know enough about the numbers and their product. All right, so here is our warm up. We have a plus bi minus blank plus blank I equals question mark. So here are some complex numbers with an unknown difference. 1. If the result of this subtraction is a real number, what could the second complex number be? So what you would need to happen here is you would need the imaginary parts to cancel out. So we would need the 4i to have a negative 4i right there to be added together. So it's going to be a real. So negative 4i plus 4i, that cancels out. Oh, no, wait, no, because this is a negative here. Actually, this would have to be a positive 4i. Sorry about that. Because you got to change both these signs here. You're basically distributing this negative sign into the complex number. So that has to be a 4i because it'll change to a negative 4i. And then this can be really any number, because it's going to be 10 minus whatever that is. So I'm just going to pick a random number. I'll call it 8. So it'd be 10 plus 4i minus 8 minus 4i. And then you get rid of the imaginary parts. So we get 2. So there's an example. Anything plus 4i there when I subtract would work. Okay, so my answer there is going to be 8 plus 4i. Obviously, answers can vary. If the result of this subtraction is an imaginary number, what could the second complex number be? So for the second complex number, we need the reals to cancel out. So 10 minus, obviously that has to be 10. And this can be any number, just make it 3, I guess. So I'd get 10 plus 4i minus 10 minus 3i. My 10 and negative 10 cancel, so it just becomes 4 plus I. So my answer was 10 plus 3i. Okay. All right, so we're going on to this part of the lesson is an info gap. So we have our problem card and our data card. So if we were doing this in class, you'd partner up and you'd have one person have the problem card, the other person have the data card. And normally they give you the problem and the data all at the same time. It's kind of a way to get your brain to think about what info would you need. So I'm going to do this. We're going to look at the problem card and we're going to see if they give us the data. So there are two complex numbers, a plus bi and c plus di, whose product is an imaginary. So that means there's no real part, just the I. What are the two complex numbers? Okay, so maybe do a little trial and error here. What are the, I guess, well, we don't really have enough info to do trial and error. We could probably come up with two that would work, but, basically what's happening here is you got your, oops. You got your, a plus bi up here, and then you got your c plus di here, and you're multiplying it out. Okay, so I would say, do they give you a, b, c, or d? I would say, do they give you the product? Let's start asking what pieces of info they have. So we're going to take a look here at what they give us. Okay, so the product of the two numbers is 34i. Oh, okay, so this whole thing here equals 34i. Okay, so we know that this part's going to be real, a times c, and then this part's going to be real. It's going to be b times d, and then I squared will make it -1 there. So I keep forgetting to change. So the real part of a plus bi is 4. So we could change the a to a 4. Because I would have asked, do they give me A, B, or C? So they give me the real part there. The imaginary part of A plus BI is negative I. Oh, okay, so now we're really in good shape here. I might have enough to do it from here, I think, and there's no more info. So let's think here. This is going to be let's see, 4C negative CI 4 DI, and this is going to be negative DI squared, right? So we know I squared is negative 1, so this is just going to be D right here because it's negative D times negative 1. So I'm going to make this just D right there. So, sorry, this looks like a 4I. It's 4C, sorry. So let's see here. These are going to cancel out. We know that these have to add up to 34I. So let's start thinking here. 4 DI minus CI equals 34I. So maybe I can make an equation here because they both have the i's. Couldn't I just say 4D minus C equals 34? Would that work? Because I don't really need the i's. And then maybe I could come here and say these would have to add up to 0. So I'm going to say D plus 4C equals 0. And what I have here is a system of equations. So I would have to use substitution or elimination to find this answer. So let's see here. Could I, maybe if I multiply this one by 4, I'd get my C's to cancel. So I'm going to get 16D minus 4C equals 4 times 34 will be 136. And then I'll just keep the bottom one the same. I'm going to add these. So these cancel. 17D equals 136. And I got D equals 8. So that's good. Plug it back into either one of these, probably this one. 8 plus 4C equals 0. (4C equals negative 8) divided by 4. C equals negative 2. So your answer is, what are the two complex? Well, we already, the one was given to us basically after we asked enough questions. The other one is going to be negative 2 plus 8I because the D goes with the I. All right, kind of tricky there, but good question to get our brains moving. All right, on to the next one. All right, so problem card 2. Two complex numbers, A plus BI, C plus DI, whose product is a real number. What are the two complex numbers? Okay, so let's get a box here and start writing it out. So the product is a real number. So that would mean the imaginary parts are going to cancel. So I got A, BI, C, and DI. So these cancel out right here. These sections are going to cancel out because it's a real number. So what we know is we know that these two are going to add up to 0. And we know that these two here, these ones are going to be the only two that we have, because this is going to give me an I squared again, which is -1. So it's going to be really BD times I squared. So it's negative BD. All right, so let's see what kind of info. I would start asking questions. Do they give me A, B, C, or D? Or do they give me the real part of either number? Do they give me the imaginary part of either number? Do they give me the product? Those are all the questions I'm going to ask. So the product of the two numbers is 12. Okay, so the whole thing equals 12. What else? The real part of A plus BI is 2. So I'm going to fill in the 2 there. The imaginary part of C plus DI is 3i. And I think that's probably all the info they give us. So awesome. All right. So let's see here. So this will be 2C. This will be BCI. This will be 6i. And this will be 3b I squared. We know I squared is -1. So I'm just going to do this. I'm going to get rid of the I squared and make it -3b. All right, so let's see if we can make some equations. So we know that these two cancel out. So if I add them up, I get 0i, really. So really it's 6i plus bci equals 0i, essentially. So really, since they all have i's, we really don't need them. We could divide the whole equation by I to get rid of it. So that makes a little bit more sense there. And then these two, if you add these up, we get 12. So we're going to get 2c minus 3b equals 12. So this is one where you might have to do a little bit of substitution instead of elimination. So let's do this. Let's move the 6 over to the right. So this top equation is going to be BC equals -6 by subtracting 6 from both sides. And then let's do this. Let's divide by B, and I get C equals -6 over B. And then let's sub this in for C. See what happens. So I'm going to have 2 times -6 over B minus 3B equals 12. So I'm going to get -12 over B minus 3B equals 12. Let's see here. What would I do now? If I multiply everything by B, that'll clear my fraction. So the B's will cancel here. I get a -3B squared equals 12B. And then let's move everything over to the right. I get 0 equals 3B squared plus 12B plus 12. And now we got to get this thing factored. So factor out a 3. So we end up with B plus 2 times B plus 2, because we're looking for factors of 4 that add to give me 4. So 2 times 2 would give me this 4, but then 2 plus 2 would give me that 4 in the middle. So it's all factored. It's equal to 0. I can now say B equals -2. Okay, so Go up here. We now have one of the real numbers. We have 2 minus 2i. Okay. Now, if I plug that back in here, I should be able to find c. And then I already have the d. So c is going to be -6 over -2, which would mean c equals 3, which would mean it'd be 3 plus 3i would be my other number. All right. A little bit harder there with the algebra, but same general idea. You need two equations. You have to do a system of equations to solve them. All right, on to the third one. All right, a little different. A plus bi, c plus di, and a plus bi squared equals c plus di. What is a plus bi? So probably want to multiply this out. So you got a bi, a bi. So this is going to be a squared. This is going to be a bi. This is going to be a bi, and this is going to be b squared I squared. We know I squared is -1. So, oops. I'll just make it negative b squared. How's that? So basically, these two are going to be the real part. These are going to be the imaginary part. So the real part's going to be a squared minus b squared. That's my real part. And then this is my imaginary part. So I'm going to just say 2abi, because these are like terms, you can combine them. So that equals c plus di. So basically what we know here is we know that, hang on one second here, let me pause this. Okay, so let's see here. So I'm going to basically start asking questions. Do I know A? Do I know B? Do I know C? Do I know D? I'm going to say, do you know the real part? Do you know the imaginary part? And see what kind of stuff they can tell us here. So the real part, so that's C. The imaginary part, so that's D. Okay, so let's start plugging these in here. We know C and we know D. Whoops, I guess I should just get rid of this. So C is -6. And this is 8i. All right, so what we could do is we could say we could set the real parts equal a squared minus b squared equals -6. And then we could say 2abi equals 8i. And if I wanted to divide each side by I could get rid of my i's to make things a little bit easier. So we end up right there. Kind of same thing as the last problem. Let's solve for A or B. So I don't know, let's solve for A. So I'm going to divide by 2b. Cancel b's, cancel the 2's. A equals 4 over b. Sub that in here. So 4 over b, square the whole thing is going to be 16 over b squared minus b squared equals -6. So let's see here. A couple things you could do here. You could probably, best thing would probably be just get rid of your fractions. So multiply by your denominator. So the b squareds cancel here. So I would get 16. This would be minus b to the 4th equals -6 b squared. Kind of crazy here. We got a quad, or we have a, to the 4th power, we have a quartic equation. So let's move everything over to the right. So I'm going to get 0 equals positive b to the fourth minus 6b squared minus 16. And then what you can do is these if I follow this like kind of like quadratic form where I go to the fourth, to the second, and your constant, you can factor that exactly like as if it was b squared minus 6b minus 16. You can factor that the same way. You're gonna if you want to set up a box, you can do a box, or you can just kind of guess and check, but do a box here. So you got your b to the fourth here, got your negative 16 here. So this would be b squared and b squared. And now you're looking for factors that multiply to give you negative 16, but then add up to give you negative 6. So I think it's going to be negative 8 and 2 because they give you negative 16. When I multiply here, I get negative 8b squared and I get 2b squared. So you add those up and I get the negative 6b squared. So what ends up happening is this gets factored into b squared minus 2 or plus 2 times b squared minus 8. So what I got to do is I got to set each one of these equal to 0. Lucky for us, we can just move the constant over and square root both sides. So this is going to be b squared equals negative 2. And I get b equals radical 2i. But remember, b is a real part. If you go back up here, or b isn't a real number. It's a coefficient in front of I. So this one we would throw out. And it would be plus and minus 2. But we're going to throw those out. So this is going to be our only answer here. Square root both sides. All right, so I get positive and negative radical 8. And then I would need to find a. So I'm going to plug it in 4 over radical 8. And it's going to be plus or minus as well. So we're going to have 4 over radical 8 plus radical 8i. And then we're going to have negative 4 over radical 8 minus radical 8i. All right, let me double check everything here, make sure that that all works. All right, I think that is good. All right, so lesson synthesis. So working backwards, so we know 34i, 4 minus I times c plus di equals 34i. So again, same idea here. We're going to have to do some equations here. So basically, four minus I, c and di. So this is going to be 4c, 4di, negative ic, and then this is going to be negative d I squared. So this ends up just being positive d. So your equations here, these two have to add up to 0 because these will be your reals, and these are your imaginaries. They add up to 34i. So 4c plus d will give you 0. And then you're going to have negative ic plus 4di equals 34i. Now, since everything has an I, you could just divide by I to get rid of them. So now I got a system, and I can go ahead and solve with elimination. Maybe multiply this one by 4. That'll get my C's to cancel. So I end up getting 8 for D. Plug it back in here. Whoops, I plugged in the wrong spot. 4 plus 8 equals 0. Minus 8, 4C equals negative 8. So your answer is negative 2 plus 8I. Which I think that was the problem we did earlier on the card. So these are actually, I'm not going to do these other two here, just because they're a little time consuming, but you get the idea how that works. Okay, so I can find real and imaginary parts of complex numbers if I know enough about the numbers and their product. And here's the last one. Here are two complex numbers being multiplied without calculating the exact result of the multiplication. How can you tell that the result will be a real number? So I'm not going to multiply the whole thing out, but I'm going to kind of set up a box here so that you can see you're multiplying here. So we would want these parts to cancel, and we get negative 12i and 12i, and those two are going to cancel. And then we know that these two are going to be real. I don't have to multiply it all out, but this is going to be real because you're going to get the I squared, which is equal to negative 1. Okay, so that would be how I would know that. So, all right, thanks for watching.